Hello friends, today I'm going to present you our project pipelines that we have implemented throughout our DevOps course. Our team members are Abhimanyu Jataria, Ankur Garg, Atit Shetty and Debushmita Das. The 4 milestones are configuration management, test and analysis, deploy and special milestone. Configuration management. In this milestone, for our pre-built task step, we have created 2 Ansible playbooks on our main server. Checkbox.io build.yml is for the Node.js application checkbox.io. Build job itrust.yml is for the Java app itrust. Both spins up new virtual machines automatically when executed. These playbooks will also provision their VMs with respective application dependencies. Both will set up Jenkins job for each of the applications. In post-built tasks, separate YAML files of each of the applications will create and configure virtual machines to run Checkbox.io and iTrust application respectively on the Jenkins server. Test and analysis. In this, we have built jobs for Checkbox.io and iTrust on Jenkins server after setting it up with required packages. For iTrust, we use a fuzzer and run it 100 times to make changes to iTrust application and build and test it. Useless test detector detects test cases which always pass in the results of these 100 builds. In the second part, we have built a static analysis tool for Checkbox.io which checks for some metrics like size of function, message chain lengths, complexity and fails the build if any such matrix is not met under limit. Deploy. In this milestone, we extend the iTrust and Checkbox.io to build jobs to use Git hooks to trigger deployment to production servers each time a build succeeds. We use an Ansible script to create and provision Amazon EC2 servers which are used to deploy both applications. iTrust is deployed on different servers. After successful build, we implement a rolling update strategy where any change to iTrust application is propagated to each of these servers sequentially one after another with some delay. Checkbox.io is deployed on 2 servers, a production server running code on production branch and a canary server running code from canary branch. We use a load balancer to redirect a part of the requests to canary server and majority to production server. If canary server goes down, all requests are sent to production server. The node running load balancer also acts as a Redis master and each of the deployment servers as Redis slaves. We use Redis cluster to implement feature flags which enables or disables certain features in Checkbox.io. In final task, we set up a Nomad cluster of 1 master and 2 client nodes. We run Checkbox.io application as a Nomad job. We simulate node breakdown for node running Nomad job and confirm that Nomad restarts the job in one of the remaining nodes. Special milestone. In this milestone, we plan to implement and study the benefits of circuit breaker design in case of failure of one of the microservices for a multi-service application. We plan to implement a scenario with 3 microservices. Here A and C depend on microservice D. D is run on a cluster and A and C connect to it through a load balancer B. We plan to store each request-response connection flow in log files and build a smart monitoring tool to detect problems with the nodes in a cluster running microservice D. The tool will analyze response status codes, timeouts, memory usage, and other metrics to detect possible problems with each node. If any node in cluster D becomes underperforming, the tool will update the load balancer to stop redirecting any traffic to such node and send a mail to the system admin. The tool will include an auto repair mode which will analyze the problematic nodes. Auto repair mode will give the node back to load balancer if it starts to work normally.
Created using Powtoon.